fourth type of chemical reaction is called a double displacement reaction. If you have a piece of paper like this, blank, get that out because I'm going to show you how to do this very easily and understand every concept that we're doing. We start with barium chloride and aluminum sulfate. These are called reagents. I go back into my chemical storeroom, they're all in bottles, they're solids, most of them are white, some of them have color, but they're just reagent bottles and we use them as reactants. Barium chloride, aluminum sulfate. And you may need to look every one of those up. So you look on your periodic table. Then I put in the oxidations, +2 - 1, +3 - 2. Then I can put in my formulas. 2 would go there, the 3 goes there, the 2 goes here. So there are my formulas for the compounds. Now what I want you to do is I want you to take this piece of paper and I want you to fold it in half, just like this. And we're going to tear the 2 halves. So you have 2 half sheets of paper. On the 1/2 sheet on this side, I want you to put the formula for barium chloride. But you're going to kind of divide this in half in your mind. The metal's going to go here, the non-metal's going to go here. So why don't you go ahead and write that. So you can see I have barium and chloride. I have ions here. That's important. Do the same thing with aluminum sulfate. You'll get something like this. Aluminum is +3. It's a cation. And here's my non-metal anion, sulfate -2. So when I look at this equation, I want to determine first, will a reaction occur? These are reagents. They're solids. So we need to put them in water. If I put them in water, they both become aqueous. By definition, aqueous means that those compounds are going to dissociate into ions, and that's why I had you put them on this paper. These, if I put it into water, split into ions. So now I want you to fold these in half again with the metal on one side, cation, and the non-metal anion on the other side, and then tear it in half. Do the same thing with aluminum sulfate. When we put it in water, it dissociates into ions, a cation and an anion. So I have barium and chloride ions, but now they're separated in water. So let's write that down up here. Barium is +2. Chlorine, watch, I'm going to write it a little different this time. 2 chlorine minuses. You'll see why I did that in a few minutes. There are these two, and you're going to set them down in front of you, just like the reaction looks. Then we go to aluminum and sulfate. Here's my cation, metal. Here's my anion, non-metal, and I'm going to rewrite these. There's 2 of those, 2 aluminum +3s, and 3 sulfate -2. So now you can see all these ions put together there. Now we have to determine, will a double displacement occur? Will these 2 metal cations switch places? Will the 2 non-metal anions switch places? And there's a way we can know that. We need a chart. This is a chart of solubility, so we want to look at all the possibilities we have. We started off with barium chloride. Here's barium, here's chloride. It is S, it means soluble. It's aqueous, it's dissolved in water. No precipitate, no solid. And we had aluminum and sulfate. It's also S, means it's soluble, it's aqueous, it's in water. But when we mix them around, we're going to look for the choices we have. Barium now can go with sulfate. You notice here, now it's an I. That means insoluble on the chart. It means it doesn't dissolve, it is a precipitate. It is a solid that exists in a liquid, just like rain, snow, sleet. So here you have a precipitate, which indicates there was a chemical reaction. In this case, it would be white. If we look at what's left over, we had aluminum and chlorine. Aluminum is here, chloride is there, and that is soluble. It means it's aqueous in water. That's how we determine this reaction. And with my papers that I made, I could do the same thing. I switched them around. Barium now is going to go with sulfate. And then that leaves me with aluminum chloride, which is what we just talked about. So let's write it into the equation. Barium sulfate, +2, -2. This was the precipitate. Saw it on the chart. What's left over are some ions. I'm going to put them below. So it would be 2 aluminums +3, along with 2 chlorine -1s. Now what I've written here has a specific name in chemistry. We call this an ionic equation. We took our original compounds, we put them in water, and they became dissociated into ions. Same thing with the other, put it in water, they dissociated into ions. So we wrote those ions out. When we mix these two, this was in one beaker, this was in another beaker, when we mixed them together, we got a white precipitate and still water, which had these in it. These are not ions. This is a compound, but these are still ions. So the overall reaction now looks like that. That's an ionic equation. But what we really want to know is, what was the real reaction? What really happened here? If you look at it, we produced barium sulfate. What produced it? Well, we know sulfate did. We also know barium did. So these 2 ions here were not part of the reaction. Therefore, we call them spectator ions. You could use different metals in place of aluminum and get the exact same result. You could use different nonmetals in place of chlorine, which was bonded to barium, and you'd still get barium sulfate in this reaction. So what happened if we rewrite that? It's going to look like this. Barium plus 2 plus sulfate minus 2 gave us barium sulfate precipitate. That is called the net ionic equation. Just like when you have a job, they tell you they're going to pay you $10 an hour. That's your gross salary. But then they're going to take out taxes and Social Security and Medicare, stuff like that. Meaning you're only going to get a net wage to take home. Same thing here. Here's the entire reaction. All the ions included, ionic equation. But this is what really happened. And this is really all we're interested in. That is called the net ionic equation. And what was left over are 2 spectator ions that were not participating in the reaction.